This is section 4.2, the converse of the Pythagorean theorem. So let's go down to the bottom of the page and we're going to explain a little bit about what converse of the Pythagorean theorem means. So the Pythagorean theorem states that if you have a right triangle, that means it's given to you as being a right triangle, then you can say that the hypotenuse squared equals the sum of the square of the legs, a squared plus b squared. That means that if you're given a diagram that looks like this, and you have your legs labeled A and B, and your hypotenuse is C, if I know it's a right triangle, then I can use c squared equals a squared plus b squared to solve for any of the sides that might be missing. Now, converse means that we're going to switch the if and the then. So this part and this part. So that's what converse is. So sometimes you can turn a statement around by switching the if and the then, and the statement will still hold true. It doesn't always work that way, but it does for the Pythagorean theorem. So the Pythagorean theorem, the converse of the Pythagorean theorem, remember THM is the abbreviation for theorem, says that if c squared equals a squared plus b squared, then it's a right triangle. So notice that I switched these two pieces. Now, the converse of a Pythagorean theorem doesn't give you a picture. It's done when you have a series of numbers, 3 to be exact, and you want to know if it's a right triangle. Now, sometimes c squared does not equal a squared plus b squared. So then we have when c squared equals, when c squared is greater than a squared plus b squared, and when c squared is less than a squared plus b squared. So that's what converse means. It means we switch the if and the then parts of the statement, and the statement still holds true. So now let's go back up to our note page and fill in some of those blanks. So first we're starting with the idea that we're given a triangle with sides A, B, and C. That means I have to know it's a triangle, but we'll get to that part in a minute. So we start with if c squared equals a squared plus b squared, that's the Pythagorean theorem. We know that that triangle is right. If c squared is greater than a squared plus b squared, then that triangle is obtuse. One of the angles in the triangle is greater than 90 degrees. If c squared is less than a squared plus b squared, then the triangle is acute, meaning all the angles are less than 90 degrees. So let's start with some notation issues. First, we're going to keep C on the left just to kind of keep it organized. Remember that C is what we're comparing things to. And so I want to have it kind of on its own side, so we're just going to keep it on the left for organizational issues. Second, remember the definition said given a triangle. Well, I got to first determine if the sides that I'm given could even be a triangle. Maybe they can't. It is possible for 3 lines to not connect to make a triangle. So the first step we have, the first thing we have to do when we're doing this is it a triangle? That means that A plus B has to be greater than C. So since C is always the longest side, I need to start by saying, is 3 plus 7 greater than 9? Well, 3 plus 7 is 10. 10 is bigger than 9, so that's a go. So the first thing I'm going to do is cross out not a triangle, because now that's not a case. So now that I know it is a triangle, now I'm going to use one of those c-squared statements, equal, greater, or less than, to determine what kind of triangle I have. So our second step is what kind? C squared equals, c squared is greater than, or c squared is less than. And that tells me what kind of a triangle I'm dealing with. We need to know what kind of a triangle we're dealing with because it changes which toolbox we can use. If it's a right triangle, we can use the Pythagorean theorem, we can use sine, cosine, and tangent, and those ratios to find missing pieces. If it's not a right triangle, then I have a whole different set of tools that I have to use to find missing information. So I need to know what kind of triangle it is first. So we come back down here, and I have c squared and a squared plus b squared. So c is 9, so 9 squared. A is 3, b is 7, that's 81. 9 plus 49, 81 compared to 58. Well, obviously, 81 is greater than 58. So when I'm looking at this, when c squared is greater, that's an obtuse triangle. That's it. We are determining if it's a triangle, and then what kind based on the size of c squared compared to a squared and b squared. So now let's look at number 2. Again, you pick the biggest side because I have to be able to say that 20 plus 21, which is 41, is greater than 29, which it is. So it's not a triangle. Then we do c squared and a squared plus b squared. C squared is 29 squared. A squared is 20 squared plus 21 squared. That's 841. 400 plus 441. 841 equals 841. So now I know that they're the same. C squared equals a squared plus b squared. So what does that mean? It means that those are, or that is a right triangle because they're equal. So now we have number 3. Again, identify the longest side. So 4 plus 11 has to be greater than 16. 4 plus 11 is 15. That most definitely is not greater than 16. That's a no. That is not a triangle. We're done. I can't do anything else with that. So as soon as you can determine that a plus b is not greater than c, no squareds, just the digits themselves, then we are finished with that problem. That problem cannot be created into a triangle. Therefore, none of the triangle rules that I know apply. For number 4, it doesn't matter that there are two of the same side. What matters is their sum. So 17 plus 17, which is 34, needs to be bigger than 22, which it is. So it's not a triangle. So then I just have to work it out. So if I have c squared and a squared plus b squared, c is 22, so we square that, and 17 squared plus 17 squared, 484, 289 plus 289, that's 484 compared to 578, obviously less than, because c squared is less than a and b, that's an acute triangle. So we're just comparing c squared to a squared plus b squared. Are they equal? Is one bigger than the other one? Which one? And that tells me what kind of triangle it is. So let's look at number 5. Number 5, the largest side is 30. So 18 plus 24, which is 42, definitely is bigger than 30. So then we do c squared and compare it to a squared plus b squared. 30 squared, 18 squared plus 24 squared. That's 900 and 900. Those are equal. When c squared equals a squared plus b squared, I have a right triangle. Number 6 is tricky because it looks like it works for just a second. So here's the longer side. 8 plus 15 has to be bigger than 23. So 8 plus 15 is 23. Is that statement correct? Is 23 bigger than 23? No, they're equal. That isn't what the rule says. It says the sum of the two smaller sides must be greater than the third side. The same is not greater. Therefore, that's not true. This is not a triangle. So just pay attention to your symbols and what those symbols really mean. Bigger is not the same as equal. So then we have number 7. It can be done with really big numbers. It just means you have to use a calculator. So 31 plus 35, which is 66, most definitely is greater than 39. So it is a triangle. So then c squared and a squared plus b squared. C squared is 39 squared. 31 squared plus 35 squared. That's 1521. And 2186. 1521 most definitely is less than 2186. That makes it an acute triangle. The last one we have, number 8, is the same fashion. Choose the largest number. That means that 11 plus 19, which is 30, has to be bigger than 28. It is. It doesn't say how much bigger, it just says larger. So 2 numbers is big enough to make a difference. So we can scratch off that it's not a right or not a triangle. Then we have c squared compared to a squared plus b squared. 28 squared compared to 11 squared plus 19 squared. 28 squared is 784. And 11 squared plus 19 squared is 482. 784 is definitely bigger. That means that since c squared is bigger, this is an obtuse triangle. So recall that the converse of the Pythagorean theorem says that if I can use the sides to determine what type of triangle, whereas the regular Pythagorean theorem says if it's a right triangle, this formula always works. So that's what converse means when we can switch the if and the thens inside the statement. And that is 4.2, the converse of the Pythagorean theorem.